Hi, welcome to our math. Today I'm doing a series of videos on the simplex method. This video is specifically on the dual simplex. The simplex method is used to maximize an optimization equation. This says minimize. So we're going to have to do a little work to be able to minimize this system. The first thing we're going to do, there's a lot of steps, I'm going to kind of short circuit them, is I'm going to write this matrix as a augmented matrix, but I'm going to add the z formula to it. So my first equation becomes 2, 3, 90. My second equation becomes 3, 2, 120. And my optimization, 3x sub 1, 2x sub 2 equals az, 1z. Okay. Now what I'm going to do is I need to transpose that. So what that means is my first column becomes my first row. 2, 3, 3. My second column becomes my second row. 3, 2, 2. And my last column becomes my bottom row. This is what I'm going to use for my simplex method. Now, if you know simplex method, usually your first columns are your variables, x sub 1 and x sub 2. But because this 2, 3, and 90 does not represent x sub 1, but rather my first equation, I'm going to relabel this first column as y sub 1. 2, 3, 90. This second column, 3, 2, 120, represents the second equation, y sub 2. 3, 2, 120. Then, in a normal simplex tableau, we get to our slack variables, but we're not going to use slack variables. Instead, we actually bring in our x variables, but we're going to set it up very much the same. 1, 0, 0, x sub 2, 0, 1, 0. And because this is not z, because we're switching everything around, we'll use the variable w, 0, 0, 1, and then we'll do our answers. Now, you're thinking, shouldn't there be a 1 right there in that corner? And the answer is no. It's going to be 0. If we had done the full system, we would have translated this into new equations, and you would see that this w came to the left-hand side. We subtract these over, negative, negative. The w comes to the left-hand side, and it all equals 0. So, just like the simplex tableau, the negatives are below the line, and what we need to do is we need to do work to eliminate those negatives. So here is our first tableau. We look under the line and we look for the largest negative, which is that negative 120. This is going to be our pivot column. Now we divide our answer column by our pivot column. 3 divided by 3 is 1. 2 divided by 2 is 1. To find out which is our pivot element. Now these are both 1. I don't know if you noticed that. So we actually can choose which one we want to do. I am going to start off by doing the 3. Okay, so if I use the 3 as my pivot element, to get what I'm doing is I'm using this 3 to zero out the other numbers in the column. Now, in traditional matrix manipulation, I would divide this top row by 3 to get my pivot element to be a 1. I prefer to not do that and get my fractions all in my last step. It will work out just fine. Okay, so my first step is going to be 3 row 2 minus 2 row 1, and we're going to put that into row 2. So 3 row 2 is going to be 9, 6, 0, 3, 0, 6, and negative 2 row 1 is going to be a negative 4, negative 6, negative 2, 0, 0, negative 6. And when we add down, we get a 5, 0, negative 2, 3, 0, 0. Okay, now we need to use that 3 to get rid of the 120. To do that, we are going to take 40 times row 1 plus row 3 and put that into row 3. So 40 times row 1 is going to be 80, 120, 40, 0, 0, 120. And then we add row 3 to this. So row 3 is negative 90, negative 120, 0, 0, 1, 0. And when we add down, we get negative 10, 0, 40, 0, 1, 120. So row 1 we didn't change, so we're going to keep row 1 as 2, 3, 1, 0, 0, 3. Row 2 becomes this new row, 5, 0, negative 2, 3, 0, 0. And row 3 becomes negative 10, 0, 40, 0, 1, 120. Now once again, we know we're done when there are no negatives below the line, but unfortunately there is still a negative below the line. That would be this negative 10. So we're going to come back up here and do the process again. We are going to use this as our pivot column. 3 divided by 2 is 1.5, and 0 divided by 5 is 0. And I don't know if you know this, but 0 is definitely smaller than 1.5. So we're going to use our 5 as our pivot element. So we're going to take 5 times row 1 minus 2 times row 2 and put that into row 1. So 5 times row 1 is going to be 10, 15, 5, 0, 0, 15. And minus 2 times row 2 is going to be negative 10, 0, 4, negative 6, 0, 0. And when I add down, I'm going to get 0, 15, 9, negative 6, 0, 15. All right, and then I'm going to do 2 row 2 plus row 3 and put that into row 3. 2 row 2 is going to be 10, 0, negative 4, 6, 0, 0. And row 3 is going to stay negative 10, 0, 40, 0, 1, 120. And when I add down, I'm going to get 0, 0, 36, 6, 1, 120. When I put this all together into a matrix, the first row becomes 0, 15, 9, negative 6, 0, 15. Second row didn't change, 5, 0, negative 2, 3, 0, 0. The third row becomes 0, 0, 36, 6, 1, 120. As always, I want to make my unit columns. So I am going to divide this top row by 15 and the second row by 5. I'm just going to move this straight over. So I'm going to get 0, 1, 3/5, negative 2/5, 0, 1. My second row is going to become 1, 0, negative 2/5, 3/5, 0, 0. And my last row is all good, 0, 0, 36, 6, 1, 120. Okay, so here is how we read our solution. This is not our normal simplex, this is dual. So notice that this is y1, not x sub 1. Because we're minimizing, we actually can pull our whole answer from down here. We find out that the minimum value is z equaling 120 when x sub 1 is 36 and x sub 2 is 6. So there is our answer. But remember way at the beginning we had those 2 1s and I said we are going to pivot on the 3. The biggest question I get is, well, what happens if we didn't pivot on the 3? What happens if we had pivoted on the 2? So let's come up here and look what happens if we come all the way back to our original problem, and instead of pivoting on this 3, we pivot on this 2. Well, ironically enough, our first is going to be the same, except instead of stuffing this into row 2, we'll put this instead into row 1. What's going to be different is getting rid of our bottom row. To get rid of our bottom row, we are going to take 60 times row 2 plus row 3 and put that into row 3. So 60 times row 2 is going to be 180, 120, 0, 60, 0, 120. And row 3 is going to be negative 90, negative 120, 0, 0, 1, 0. When we add down, we're going to get 90, 0, 0, 60, 1, 120. So our first row is going to become this. This first row is going to become this 5, 0, negative 2, 3, 0, 0. Our second row is going to stay the same, 3, 2, 0, 1, 0, 2. And our last row is going to become 90, 0, 0, 60, 1, 120. And if you look closely, you'll notice we don't have any negatives below the line. We do need to divide this through by negative 2 to make that a unit column. We do need to divide through by 2 to make this a unit column because we want to make sure we have our unit columns. So we're going to have negative 5 halves, 0, 1, negative 3 halves, 0, 0, 3 halves, 1, 0, 1 half, 0, 1. Our last line is going to stay the same, 90, 0, 0, 60, 1, 120. And what you're going to notice is y sub 1, y sub 2, x sub 1, x sub 2, w. Again, our answer is coming from down here. Our minimum is going to be z. Our minimum is going to be z equaling 120 at x sub 1 is 0, x sub 2 is 60. It's a different answer. What's happening is both of the minimums were 120. If we were to graph this out and get our 30 and 60 and 40 and 45 and look at the geometric solution, this answer, which is 36.6, and this answer, which is 0.60, both give the answer of 120. So there are two ways to solve this. There are two answers to get, but in the end of the day, they actually give the same answer. They are giving different intercept answers that are possible. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on my next video. Thanks.